For number 11 of the midterm review packet, we have p squared minus 4p minus 32 all over p plus 4, and I think we're supposed to simplify. Now the group that did this decided to factor it first, and I think that's a good idea because we see a p plus 4 and a p plus 4 factor appears in both the numerator and denominator. So let's cancel those out. That leaves just a 1 in our denominator and makes our denominator unnecessary to write. So this all simplifies to just p minus 8. Now the other part of the problem asks us to identify any restrictions on the variable. If we go back to the original problem, we see a p plus 4 in the denominator. If p is negative 4, it's going to cause the denominator to be 0. So our only restriction is that p is not equal to negative 4. If you need more help with this problem, check out page 573. Good luck. For number 12 of the midterm review, we have to simplify the rational expression and state any restrictions on the variable. So to do this, we're going to factor the numerator and factor the denominator. For example, the denominator factors to q minus 8 times q plus 3. I'll let you factor the numerator and see if any of these terms will cancel out. But let's talk about stating any restrictions on the variable. Notice that if q equals 8, or if q equals negative 3, we have a 0 in the denominator. That's bad, so that would be a restriction. So the two restrictions are going to be q cannot equal positive 8, and q cannot equal negative 3. Now if you need more help with this problem, check out example 1 on page 573. Good luck. This is midterm review problem number 13. In this one, we have to multiply or divide and state any restrictions on the variables. This little dot here means multiply. This fraction times this fraction. Now when multiplying and dividing, it's helpful to factor all the numerators and denominators first. So factoring z squared, we just have z times z. When factoring z plus 1, it is what it is. Up here, this trinomial factors out as z plus 1 times z plus 2. You can confirm this by foiling it. Finally, down here, we could factor a z out of each of these terms. I'll let you cancel it, but let's talk about state any restrictions. Restrictions are any values of z that would cause a denominator to be 0. For example, if z was negative 1 right here, this denominator would be 0. And a 0 in the denominator is undefined. So that would be a restriction. Z cannot equal negative 1. What else can z not equal? If you need more help on this, check out page 575 and 576 from lesson 8.4. For number 14 of the midterm review packet, we have to add or subtract and simplify if possible. In order to add fractions, they have to have a common denominator. Right now we have a plus 8 as the first denominator, and a squared minus 64 as the second denominator. Now you may notice this is a certain type of binomial. In fact, it's a difference of squares. So you can factor a squared minus 64 as unfortunately, they're not a common denominator yet, but perhaps there's something you could do to this first fraction, a certain 1 you could multiply it by to give them a common denominator. If you need more help with this, check out page 582 in your textbook. Number 15 of the midterm review is solve the equation and check the solution. Here we have a fraction that's equal to another fraction. A common strategy for solving this problem is cross multiply. This g plus 4 times g minus 8 is equal to g minus 2 times g minus 5. So let's actually write that out. G plus 4 times g minus 8 equals g minus 5 times g minus 2. You're going to have to FOIL each side out and then use algebra to solve for g. At the very end, you need to check your solution. The reason why is because if your solution happens to be g equals 2, that won't work. It'd be extraneous. It would make that denominator 0. There's another denominator, there's another value of g we wouldn't want to have, because it would make this denominator 0. But I'll leave that up to you to find out. Finally, if you need more help with this problem, check out page 589, exercise 1. Okay. This is midterm review problem number 16. Here we're asked to write an equation of a parabola with the vertex at the origin, or 0, 0, and a focus at -2, 0. Now, the strategy here is to graph this and try to figure out what type of parabola we have. A helpful page for this is 620. Parabolas either point up or down, those are with x squared terms, or they point right or left. That's if the y term is squared. And we can determine that by looking, is p positive or is p negative? So in this case, graph this, see what's going on, and try to figure out which type of equation you're going to have from page 620. Number 17 of the midterm review packet says graph this. What is this? Is it a circle, an ellipse, hyperbola? It's actually a parabola. There's one tiny tube. Now, since y is the squared term, we know this is in the form y squared equals 4px. What can we do to our problem to put it into this form? Right now we have a 1/5 with the y squared. We want a coefficient of 1, so I guess the first step could be multiply both sides by 5. So we'd have y squared equals 5x. Now try to figure out the value of p and use that information to graph your vertex, your focus, and your directrix. Finally, because this is a y squared and not an x squared parabola, we know it's going to either open left or right. If the value of p is negative, it's going to open left. If the value of p is positive, it's going to open right. If you need more help on this problem, check out pages 620 through 621. Good luck. Number 18 asks us to write an equation in standard form of an ellipse that has a vertex at 5, 0, a co-vertex at 0, -3, and it's centered at the origin. I think I would start this problem by graphing it. If we know the center is at 0, 0, and one vertex is at 5, 0, try to figure out where the other vertex would be. We also know a co-vertex is at 0, -3. Try to figure out where the other co-vertex would be. Now, if the ellipse ends up looking like this, sometimes in class we've called this a Burt ellipse. we'll have the a squared term underneath the y squared term. And the vertices will be vertically aligned. The other type of ellipse we've been calling a Ernie ellipse, and this looks like x squared over a squared plus y squared over b squared, where the a squared is under the x squared term. In this one, the vertices will be on the horizontal axis. If you need more help with this problem, check out page 634. Number 19 of the midterm review packet says, identify the conic section. Let's start with just that piece. Now we can do this by calculating the discriminant. To find the discriminant, we look at b squared minus 4ac, where b, a, and c are all coefficients from this big standard form it's written in. If you need more help finding the discriminant, check out page 654. Anyways, a is 4 and c is 7. So the coefficient of the x squared term and the coefficient of the y squared term. If we plug that into this equation, we actually don't have a b in this situation, so we have 0 minus 4 times 4 times 7. It's some large negative number. Because we see a and c are different values, this tells us that this particular equation is that of an ellipse. So we know it's an ellipse. Now let's read the rest of the problem. If it's a parabola, give the vertex. It's not, so we don't need that. If it's a circle, give the center and the radius. We don't need that. If it's an ellipse, okay, now I'm listening, or a hyperbola, give the center and the foci. So from this, we're going to have to figure out what is the center of this ellipse and where are the foci. To do this, we're going to use completing the square. Let me get it started for you. Let's group the x terms. So we have 4x squared plus 32x, and we'll leave a space there. Now let's group the y terms. 7y squared minus 56y, and we'll leave another space there. And now we're going to move this 148 to the other side, because it doesn't have an x or a y in it. So it will be a negative 148 if we subtract 148 from both sides. The next steps involve factoring out this 4 and factoring out this 7, then completing the square and being sure to add anything you add to this side to the other side as well. It's very difficult. Good luck. Number 20 of the midterm review packet says graph y equals 4x. Now if you don't know how to graph this, one way to do it is to check out page 478. And that will tell you this is in the form y equals a b to the x power. And there's some tricks associated with that. Another method is simply make an xy table. If we plug in values for x, we can find out what y would be. For example, when x is 0, 4 to the 0th power is 1. When x is 1, 4 to the first power is 4. 4 squared is 16. And you could keep plugging in points until you had enough to graph the graph with the coordinates 0, 1, 1, 4, and 2, 16. So if this method doesn't help you, go ahead and try checking out page 478. Good luck.